So this is lesson 6.1 in elementary algebra, called the greatest common factor and factoring by grouping. So just a couple bits of information I want to give to you before I get too far into this, and it all has to do with just understanding some vocabulary so that we're on the same page here. Now when we multiply two numbers together, we have a couple parts. We have the answer, which is called the product. And then we have two, in this particular one, two factors, the 3 and the 5. So when we start with 15 and we say, what numbers can I multiply to get 15? We're asking for what are the factors of 15. Now when I take my factors and multiply them, then I get a product. Okay, so that's what we're doing, going back and forth. So what we're going to do is we're going to start with our product. We're going to start with our answer, and we're going to look at seeing where the answer came from by finding out what those products are. So for example, if I have x plus 2 times x plus 3, and I get x squared plus 5x plus 6 as my answer using the FOIL method, this is my product, and each of these are my factors. These are the things that I multiply to get my answer here. Okay, so factors, product. Okay, and if you remember, a while back we were talking about prime factors. So anytime we have a number like well, let's say 24, and we want to know the factors. Well, we have lots of factors. We have 24 times 1, 12 times 2, 8 times 3, 6 times 4. So, we've got those factors. But if I'm looking for prime factors, it means that what are the factors that are all prime numbers that when I multiply, I get 24. So, for example, 2 times 2 times 2 times 3. If I multiply all four of those numbers together, I get 24. And the thing that's unique about these is each one of these numbers are prime numbers. So, they're called prime factors. So if I'm asking for the prime factors of 24, I'm asking for what numbers that are prime can I multiply together to get my 24. And in this case, we get that. And that was on your test number 1. There were some problems like that that asked for the prime factors. So now what we're going to do is we're going to get into this next piece that's talking about not only prime factors, not only factors, but in this case, greatest common factor. All right, so a greatest common factor is the largest factor, or what they say in the book is the largest monomial, that divides each of the polynomials. So, for example, if I have 3x plus 12, and I'm looking for the greatest common factor, what I'm looking for is the largest number that goes into this monomial, or this term, and the largest one that goes into this one. What do they both share? They both share a 3. The largest number that goes into 3 is 3. The largest number that goes into 12 is actually 12, 12 times 1, but it has to be the same as over here. So we're looking for the largest number that's common to both of these. And the largest number that goes into 12 that also goes into 3 would be 3. So the greatest common factor there would be 3. So if we want to, what they call factor this problem that I have right there, what that means is we are going to go back to the groups of numbers and letters multiplied together that will give me 3x plus 12. So remember how I said 3, or in the a minute ago in one of the problems I said x plus 2 and x plus 3 equals x squared plus 5x plus 6. So we started with that and we wanted to know what we multiplied together to get that. It's the same thing here. This is our product, and we're looking for two numbers or two groups of numbers and letters multiplied together that are going to give me that back. So the first step in doing that is to find the greatest common factor, or what mathematical nerds call GCF. So we pull out the greatest common factor, and what we do is we write whatever's left. So if we pull a 3 out of there, we don't have a 3. Basically what we're doing is we're saying 3 divided by 3 is 1. 3 goes into 12 4 times. Because then if I distribute this, I get my 3x back and I get my 12 back. So this right here are my two factors that I can pull together, or I can multiply in order to get my 3x plus 12 back. So if I have a problem like example, what is it, example 1, and I want to try to get rid of all this stuff, it takes forever. I've got 3x to the 5th plus 12x squared. Alright, so what I'm going to do there is I'm going to take this and find the greatest common factor. What are the greatest numbers that are the greatest numbers or letters that are factors of those two terms there, the 3x to the 5th and the 12x squared? Alright, so we already said that the greatest common factor of 3 and 12 is 3. And that left us with x to the 5th plus 4x squared. So one of the key things is, you know, this is the greatest common factor if you can take this times this and get that back, this times this and get that back. Alright, but notice we still have some common stuff going on. We have an x here and an x here. Well, the greatest common factor will always be the smallest exponent of the two. So I've got an x squared and an x fifth. So the greatest common factor of my x's will be an x squared. And what does that leave me with? Alright, so when you're looking for exponents on what you have left, it's going to always be 5 minus that there. Plus 4, 2 minus 2 is 0. So your variable doesn't exist because you pulled them all out of there and there aren't any left. When you pulled 2 out of here, you still had 3 left. So this is my greatest common factor. That's what they're looking for here. And I went a little bit further and showed you what was left there, because I think what's left is important, because eventually you're going to have to do both of these. So let's keep practicing some of these. And again, as we get going, some stuff that I've been doing for years doesn't necessarily mean you have. And sometimes it's a little bit tricky to catch on to everything that's going on. Okay, so there we are. And the question for example 2 says, all right, find the greatest common factor. So one of the things I'm going to do is I'm going to try to find the biggest number that goes into 8, 16, and 20. Well, 8's a pretty big number. 8 goes into 8. 8 goes into 16, but 8 doesn't go into 20. So when you're kind of fighting through what numbers work, what I like to do, and it's kind of up to you whether you just do it a different way or do it this way, is I like to write as the prime factors. Okay, so there's my 8, there's my 16, there's my 20. Alright, so what I'm going to do is find the numbers within my prime sets here. And I hope this doesn't get too complicated. I'll try not to let it get that way. So what I'm looking for is the numbers that are common to all 3 of these box sets. So I've got 3 2's there, 4 there, and 2 there. Well, what's common? Well, what's common is 2, okay? Because I've got 2 there, 2 there, and 2 there. I couldn't have picked 3 2's because I have 3 here, but I don't have 3 here. And I have a 5 here, but it doesn't occur anywhere else, so those aren't common. So what I'm looking at are the numbers that are common to all. Once I find that, that ends up being what I pull out as my greatest common factor when it's concerning the numbers there. Okay, now let's look at the greatest common factor that has to do with the letters. All right, let's look at the A's. I've got 3 there, 2 there, and 3 there. Well, what did I say earlier? The greatest common one is the one that occurs the least. That one right there. So I'm going to pull that out. And then I'm going to look at my B's. Well, I've got 2 there, 3 there, and 3 there. The one that occurs the least is that B squared. Okay? Now I'm going to write what's left. How would I change, what would I multiply that 4 by to get this 8 back? A 2. All right, I pulled out 2 of the 3 A's, so how many do I have left? I have 1. I pulled out 2 of the B's. How many do I have left? Well, I pulled both of these out, so I have none left, so I don't even have to write that. What number times 4 is going to give me my 16 back? 4. What about my A's? I had an A squared. I pulled both of them out, so I don't have any left. I have a B cubed. I pulled 2 of them out. That means I have 1 left. What number did I multiply by 4 to get 20? 5. And if I pulled 2 A's out of here, how many do I have left? 1. I pulled 2 B's out. How many do I have left? 1. And now what I have is I've got the greatest common factor, and I have what was left. Now, again, if I multiply this and I distribute times this, I will get this back. This times this, I'll get this back. This times this, I'll get this back. So do you see how these two are the factors, and this is the product. This is the answer. So I just took the answer and I went backwards and wrote what I need to multiply in order to get the answer. So example 3, they're trying to throw a little bit of a tricky one in here at you. They're asking you to find the greatest common factor. What is the factor that's common to this and that? All right, so remember when I was showing the product of primes? So the primes, or the product to get 2 is just 1 times 2, right? And what do we multiply to get 9? 3 times 3. But we also can be multiplied by 1 as well, right? 3 times 3 is 9, times 1 is 9. So 1 is also in there as one of your prime numbers, but you usually don't show it unless you run into where there aren't any other numbers except the 1 that's common. So the GCF for this one is actually 1 because there aren't any other numbers besides 1 that I can pull out. Okay, so let's go to factoring the GCF from a polynomial, which is exactly what I've been doing all along. And we'll do that in the next video.